Alright, we are solving for how fast the marble in a roller coaster is going at the top of a loop. Our two equations for this are going to be potential energy, which is mass times gravity times height, and kinetic energy, which is half mass velocity squared. Right now I'm just drawing out a picture of what this is looking like as a roller coaster. I'm going to be solving for the potential energy at the start of the roller coaster, which is 1.9 meters high. And then I'm going to be solving for the potential energy at the top of the loop, which we know is 1.14 meters high. This is both relative to the ground. And right now I'm going through and plugging in the numbers to calculate it for potential energy for at the start of the roller coaster. When you calculate it out, you get 0.0931 joules of potential energy at the top of the roller coaster. And right now I'm going in and all I'm doing is changing the height or position of the marble because it has went through some of the roller coaster and it's lost some of its potential energy and has gained kinetic energy, and I'm using 1.14 for my height instead. So now, because if we know what the potential energy is at the start and we know what it is at the top of the loop, and if we want to solve for what it is at the top of the loop, the law of conservation of energy states that a loss in potential energy with no friction equals a gain in kinetic energy. And so when I subtract from the top of the hill when it has max potential energy and it has no kinetic energy, if I subtract the potential energy of these two things, I get how much kinetic energy was gained during the course of it losing the potential energy going through the roller coaster. I'm just writing that out right now, and that loss in energy was 0.03724 joules of kinetic energy, and gained in kinetic energy. It's very important that this is calculated without friction, so the final velocity and my energies are going to be off by a little bit because the force of friction is not being calculated in with this problem. So when you do this, since these two amounts are equivalent, I can plug in what I got for my potential energy into my equation for kinetic energy, 1/2 mass velocity squared. And at this point, you lose a lot of the conceptual parts. You've already done most of the work of the problem. It's just going through the algebra. 1/2 times your mass of 0.005 kilograms times velocity squared. You multiply that out, you divide by 0.0025, and to isolate the velocity variable, that equals 4.86. However, you don't want to just leave that as is because it's velocity squared, and you will be off every time if you forget to take the square root of the number you get. And sorry, it was 14. And then when you take the square root of that, you get 3.8595 approximately meters a second. And that's how fast, with no friction, the marble would be going. However, because this is a loop, it's going to be going uphill, and that's when it's going to lose a lot of its velocity. So this would not be nearly equivalent, which is what I'm writing out on the paper right now.